All right, so now it's time for the network design challenge number 1. The idea here is we present a question that's worded and constructed much like an exam question, and you should budget yourself about 2 minutes to read the question and come up with the answers. So once you see the question, pause the video, give yourself 2 minutes, then when you have the answer, resume the video and I'll explain what the answers are and the whys and why nots. Get ready, because here comes the question. Okay, welcome back. Hopefully you've managed to formulate an answer. The question posed here was a bit of speculation on our part, but this is very representative of exam questions, and this is actually representative of real life situations where you have to somewhat speculate on what could be the problems to help focus your efforts. So if we look at the question, we have two main pieces here that we want to pay attention to. One is that the connectivity between VPC A and D is slower than they want it to be. So it doesn't say that it's non-existent, it's just slower than they want it to be. Now, slow is a relative term, but let's set that aside for now. And we're asked to select some valid reasons that might explain this situation. So we have to choose 3. So what we can do is we'll go up to the top here and we'll start with A. And it says they forgot to turn on enhanced peering mode on one of their VPCs. Well, there's no such thing as advanced peering mode, so we can eliminate that one straight away. For B, transitive peering is not supported, so they must restructure their connections to not require it. Well, it's true that transitive peering isn't supported natively by AWS, but that doesn't explain slowness, because if it wasn't supported, then they wouldn't have any connectivity, but at least they have slow connectivity. So we can eliminate that one. C says the regions containing VPC A and D are physically too far apart to meet their expectations. Well, that's a perfectly valid reason why it might be slow. Maybe they put one VPC in one region, then VPC D on the other side of the earth, and the latency is just too much for either their liking or their application. So we like C. Let's move on to D. Although VPCs A and D are peered, the routing table in VPC A does not have an entry for VPC D's CEDAR block. Well, this is one of those all or nothing items. And if we didn't have a route in the routing table in A, then we wouldn't be able to reach D. But here it seems like we are able to reach it. It's just a little slower than they want. So option E is the internet gateway they attached in either VPC A or VPC D does not have enough bandwidth to handle the required data volume. If you recall, internet gateways do not have any real bandwidth limits that we would hit, so that's probably not a reasonable answer. So if we go on to F, they have configured a hub and spoke network via VPN where both VPC A and VPC D are connected via a route on their corporate network. So if they're routing traffic all the way back to their corporate network, rather than routing through VPC peering, the speed between the two VPCs would then be limited by the speed of their connection to each VPC back to their corporate network. And if they have an undersized or maxed out internet connection, then the VPN connection speed would suffer as well. So that's a possibility. I like that answer. If we move on to G, they have reached their account limit on VPCs and must request a limit increase or reduce the number of VPCs. Again, this is one of those all or nothing items. Account limits are generally enforced when you try to create a new thing. So when I tried to create a new VPC, if I had reached my account limit, it would prohibit me from doing that. Choice H is they have enabled jumbo frames on their hosts inside their VPC. Now, some EC2 instances do support jumbo frames, but the standard Ethernet MTU is 1500. And jumbo frame traffic going outside of VPC will be fragmented. And fragmentation will tend to slow down traffic. So this is a plausible answer. So here are our answers, C, F, and H. So how'd you do?